Hello students, the last class we have seen sections of solids, basics of sections of solids. In this class we are going to see some examples given the sections of solids to solve the problem given. First problem we are going to see section of a cone. Problem: a right circular cone diameter of base 60 mm and height 70 mm rest on its base on horizontal plane. A section plane perpendicular to horizontal plane and inclined at 45 degrees to vertical plane cuts cone in 10 mm in front of the axis. Draw its top view, sectional front view, and true shape of the section. So first, there is object we are going to see this. This is a cone of base diameter given 60 mm and height 70 mm, which is resting on a horizontal plane. So the condition is resting on horizontal plane on its base. So on horizontal plane, we are going to get cone, circle, front top view that we are going to draw below x value. In front view, we are going to get a triangle. We are going to see how it is section cuts the pyramid 45 degrees and passes at a distance of 10 mm away from the axis. So either it can you draw towards or either side. So here it is perpendicular to HP and inclined at 45 degrees to vertical plane. So it is the red color line shows the cutting plane, which is cutting 10 mm away from the axis and inclined at 45 degrees. So the details as given here, cutting plane. So I hope you have understood the problem. Cuts the pyramid at 45 degrees and passes at a distance of 10 mm from its axis. So this is a cone, a three-dimensional view. The circle is resting on a base circle on horizontal plane. So top view we are going to get a circle. This is a top view of a cone. Then now we are going to see the front view of a cone, which looks like a triangle. This is the front view of the triangle. This is top view. And now we are going to see the sectional view of a cone, which is inclined at 45 degrees. Here it is being shown. The section plane, now it is parallel to axis, but it should be inclined at 45 degrees. So this inclination will be shown now, 45 degrees inclination. And the distance from the axis is 10 mm. So the sectional plane. So this is top view of the after section plane. The full circle is cut. And this is the front view of the section cone solid. And this is a top view as I have shown previously. Cutting plane is clearly seen here, and this is the blue color shape. What is being seen is the sectional view. So top view, we are going to get a circle first, the base of the cone. So here you can see the two views which I have shown you previously. This is a circle which is below XY line. And front view, we can see we are dividing it into 8 equal parts, which of radius 30 mm. Dividing it into 8 equal parts, and we project its front view. We call this O1, O2, O3, O4. We represent here. Those will be called as generators. The just assumptions O1, O2, O3 till O8. And generators are produced to XY line, and axis is height of the given axis in the height. So all those points will be projected 70 mm axis height. All the points will be joined with these generators 1 dash, 2 dash, 3 dash, 4 dash, 6 dash, 5 dash, 8 dash, and 7 dash. So these are joined with O dash. Now This is a front view and top view what we have got. So now we are taking a 10 mm point from the axis, away from the axis, and because O dash 3 dash is the axis and which is seen as a point. O is the axis. From axis 10 mm away, we need a section line 45 degrees inclined to vertical plane, and that is the darker portion is section plane. Now if you represent, if we see this projected towards the front view, we get the sectional front view. A dash, B dash, A, B, C, D, E is the points where the section plane is cutting the cone in top view. So A, B, C, D, E will be projected onto the front view. Then we get sectional front. So first we have A in between 2 and 3. So A is projected upwards between 2 and 3. So this is a point where we get A dash, and B we see here. B is on, it is coinciding with O dash 3 dash. It is on O3, it is coinciding on O dash 3 dash. So we'll see that to get B, since it is coinciding there, we need another procedure to get it. So keeping O as center, OB radius, taking OB radius, we drop on O1, which is a parallel to X value. From there, we produce it upwards till the longest generator, which is O dash 1 dash. From there, we produce on the axis, where we get B dash. And next, we go for C dash, which is cutting O4 and which is projected upwards, which is C dash. And D dash is on O dash 5, O5, which is D dash, and E is on 6, 5, where we get on 6 dash, 5 dash in front. So joining all this A dash, B dash, C dash, D dash, and E dash, we get sectional front view, the darker portion, which is shown here. And the hatching is done. So the remaining part, like 1 dash, O dash, remaining part also should be darkened here. So this is the sectional front view and the top view. Now he has asked us to draw the true shape of the section also. So we have to take a parallel line x dash y dash or x1 y1 based on some textbooks. So when we produce it A, B, C, D, E, so we produce a perpendicular lines to x1 y1. So we have to take the points where it is, see A dash is on xy. So the same point is projected on x1 y1. So A1 is on x1 y1. So the same it is produced and it is represented on x1 y1, capital A. Now regarding B dash, mark the distance, take from the distance from xy to B dash and mark it from x1 y1 on the same line. Now capital B. Similarly, like to get C dash xy, x1 y represented from x1 y1 to get capital C. D dash, one leg of the compass on xy and another point on D. So we have got D. Then E is projected on xy, so E is projected on x1 y1. So joining capital A, B, C, D, E, we get the true shape of the section. So this is how we get true area or true sectional view of the cut solid. So this is one example of sectional front view, top view, and true shape of the section. So this is the problem regarding it. I hope you have understood. This is another problem of prism. A pentagonal prism, 30 mm side, and the axis given is standing on horizontal plane or on its base, whose one side is perpendicular to VP. It is cut by a section plane 45 degrees inclined to HP. Through midpoint of the axis, draw front view, sectional top view, and sectional side view. Also draw true shape of the section and development of surface of remaining solid. Now developments we are going to see in next class after starting the developments, after completing the basics of the developments. But in this class, we are going to see only 3 sections. So the steps. So first, to the XY line, since it is resting on horizontal plane, we are going to get base on horizontal plane which is below XY. But while drawing pentagon, there is a statement said standing on HP whose one side is perpendicular to VP. So we are going to get 5 sides here below XY line, out of which one side should be perpendicular to VP, that should be perpendicular to XY line. So this is a pentagon where one side is perpendicular to VP. Now we get this A, B, C, D, E are the corners of the pentagon. Now this is the height of the pentagon. The axis, the dotted line previously was seen, this is the axis. And this point is midpoint of the axis, where it is cut by a sectional view, sectional plane, 45 degrees inclined to horizontal plane, and which is being cut at A dash, B dash, E dash, because we have B and E are coincided on this line. So we have B dash and E dash. On this line, we are coinciding with C and D. So it is called, we are getting C dash and D dash. To get side view, because he is asking us to draw the sectional side view, we need to draw the side view of pentagonal prism, which we are going to get same height. Producing this A dash, B dash, E dash, C dash and D dash. Now, A dash is on this line here, and here it is coinciding with A dash. A is on this line, coinciding with A dash. Similarly, B dash is here, which is coinciding here. C dash coinciding here, this point. Similarly, like E dash and D dash also coincides here, these points. These are the points where we get the coincidence of the section plane. We get a pentagon here. But even that is not the final true view, true shape of the section. Now we cannot see D dash and E dash inside view, C dash inside view. So those are represented with a dotted line. And this is a hatching, so it is because it is section. Right. So to get the true shape of the section, we need to draw x1, y1, which is parallel to the cutting plane, as we have seen in the previous problem for a cone also. Now, we need to draw lines from A dash, B dash, E dash, and C dash, D dash, which passes through x1, y1, which are perpendicular to x1, y1, obviously. Now, first, these points are represented. The first point, we need to take the distance from xy to A. And this xy to A is represented from x1, y1 on the same line. To get B dash, one leg of the compass on xy, on another leg on B. The distance is taken from xy and it is represented from x1, y1. Similarly, E also it is represented taking distance from xy to E, and same distance is represented from x1, y1. These two distances, like this is E and this is B. This is A, we have seen. Now we need to represent C and D. Take the distance from xy to D, represent it on from xy, x1, y1 to D here. Repeat the process for C also. This is D, this is E. Joining all these points, we get a true shape of the pentagon. We need to hatch these also. So this is sectional view of pentagon. Previous problem we have seen cone, which is a family of pyramids, and there we have drawn sectional top view, and this is a pentagonal prism, and here we have drawn sectional top view. There we have drawn sectional front view. So there we have cone, we have drawn sectional front view. Here we are drawing sectional top view. So I hope you have understood this class. Thank you.